Welcome to my Superliminal tutorial series. In this first part, we're going to be looking at creating the force perspective mechanic that you can see right now. And, well, we'll also be adding a rotation effect that you can see. So let's get straight into it. So to get started, you're going to need to launch UE, in my case 5.1.1. So feel free to use whichever one you're using, but it's obviously going to be less risky if you use mine. The same one as me. So let's go ahead and do that, wait for the project to load. Okay, so once you have the Unreal Project browser, we're simply going to select Games and First Person. We don't need the quality to be at maximum, so we'll just put Scalable, and let's just call it Superliminal Tutorial. Let's go with that. So, wait for the project to load. This part we're going to be working on the movable objects. Okay, so once your project's loaded, it's going to be preparing the shaders. So while it does that, we can get the other stuff ready. So the first thing we're going to actually need to do is we're going to make a new level. But before that, let's just create a folder that we'll call, well, Superliminal. That way it's separate from all the rest and you don't mix it up with the other stuff. So, as I said, the reason we're making a new level is because inside of the default level, the world partition system is activated, and it can sometimes cause issues with objects disappearing. It's a bit weird, so every time I usually create a new level because of this reason. So I'd suggest doing the same, that way you don't have any weird issues. So we go into File, New Level, and we're just going to select Basic because we don't need too much. So with our new level, Control S to save it, and we'll put it in Superliminal. Superliminal, sorry, I keep getting that wrong. Let's just call it testing. Doesn't need to be anything particular. So with our level ready, we can move on to, well, getting our assets. So the first one we're going to make is going to be our player character. So you're probably wondering why. Well, because it's just to keep it separate. There's a class system and an object-oriented code, it's for a reason, so let's just make a new one. So select all classes, and we're going to look for first person, and we're going to select the character. So select that, and we'll call it FPS underscore Superliminal. Now, we can leave that as it is. We just need to do one change before we should keep going, is we're going to need to change the world settings. Otherwise we're going to spawn with our basic first person character. So click on the plus sign here to create a new game mode blueprint. And we're going to put it in Superliminal. And we'll call it GM underscore Superliminal. Again, now that's going to create all the default stuff for us. Now we can go ahead and actually open it, and inside of it we're just going to, oh, it's opening on the wrong window, give it a second, there we go, so it's open now. So we're just going to quickly change the default settings by going into the default pawn and actually changing that to our new one, which is FPS Superliminal. So now we don't need this anymore, close it. And we're going to make a few changes to our character, obviously, but the first one we need to make is we actually want to remove our mesh, because we don't want to see that, because it's going to make more complications later, and plus it will allow us to see the difference between our one and the original Unreal Engine mannequin. So select the skeletal mesh and select clear. Okay, with that done, we can move on. So we're going to start with our procedural, sorry, I'm still in Viewfinder mode here. We're going to start with our folders and some of the objects. So we'll start with our inputs and another folder for our assets. So for the inputs, we're going to actually make two. So first we're going to create our input for the interact. So we'll call it interact. And the second one we'll just duplicate from here and we'll call it rotate. So if I interact, we leave it as is, but we want to add a trigger for pressed, because we only want to call the event when we actually press the button and not hold it. Next we have rotate, and rotate we leave as is, except we change the axis because it's going to be scrolling with the mouse, which will allow us to rotate the cube or any object we pick up. Now we need to make our context mapping, so we're going to do that. IMC underscore Superliminal, and we'll be adding our mapping. So add, and then we need to select it, so interact. I'm going to put F, you can do whatever key you want. Next we want to add the rotate, and we'll put the scroll, so scroll your mouse once you select here. So we're done with the inputs. Next we're going to go and actually make our logic for the actual cube. So we're not actually going to work on the player right straight away. First we want to get the cube working. So a new blueprint class, an actor, which we'll call actor underscore movable. Now, with the cube movable, we're going to open it, and we're going to add a static mesh. So we'll leave it as static mesh, there's nothing we need to change, and we'll give it a default of a chamfer cube. So we're going to simulate physics because in most cases we want it to actually drop and be interactable with physics, but we're going to be disabling that when we pick it up, so don't worry about that for now. So as far as the blueprint goes here, there's not that much we need to do. There's only two small functions and a few booleans. So the first boolean is going to be locked, which in essence is going to be a way for us to tell the cube whether we want it to be able to move. So it's going to be exposed because we want to be able to change it on each case. And another one we're going to call is held. Now is held doesn't need to be exposed, so we can click that to turn it off. So now we want our two functions. So the first one is going to be self drop, we'll call it. And the second one is going to be called self pickup. So we're just going to be calling these functions, some of the logic for picking up the object inside of the object itself, so it's easier to manipulate later. So the two functions only take an input for the self pickup, because we need to actually tell it what it's being attached to. So we're going to call it parent comp here, and it's going to be a primitive component. Now primitive component is going to be our first person camera, but now we're just going to build the logic on this side. So for self pickup, we actually also want to add a boolean on the output. The reason we're doing that is that we can also tell it if it failed to pick up for whatever reason. In our case, if it's locked, we don't want it to pick up. So we're going to do that and say, we'll call return value simply. So the first thing we want to do before anything else is we're actually going to check if it is locked. And if it is locked, true, we're going to return false here. So we'll just leave it like that. On true, on the other hand, we want to get a reference to parent comp. So get that here, and we're going to say attach components to components. So we're not looking for the target though, we're actually looking for our static mesh for the target. So make sure you put keep world and keep world to this here, because we're actually going to be snapping it to the 0, 0, let's say, inside of the player controller, or player character more like, so that it's more smooth than having it snap immediately to 0, 0. So then obviously, as I said before, once we pick up, we want to set simulate physics to false, but we also want to disable collisions, enable to false. So make sure it's at no collisions, and attach this here. And to finish, is held obviously becomes true because the object is being held right now. Then return value, and this time it's true because we succeeded in what we wanted to do. So for self drop, we're going to want to do the opposite pretty much. So we just want to get a reference to static mesh and say detach from component. And once again, we want it to be world, not relative. So let's go and attach that. We want to go and reset our set simulate physics to true and set collisions enabled to our query and physics again. And to finish, held to false. Go. So with that, we're done as far as the cube goes. I'm just going to double check to be sure. Let's just make sure our collisions are correct, because that can usually cause an issue. So it's changed correctly, no problem. So I'm pretty sure that's everything. So just a heads up for those of you who are using another mesh that's different, for instance, from the chamfer cube. If you use another mesh, there's a chance that you might have an error. If you look at the collisions here, we have project default. You might get an error that could be caused by using complex collision as simple or using complex and simple, but you'll get a warning for that. The code should still work, but you'll have a warning that'll appear. So normally it's pretty clear of what you need to change, so if you see that, just go ahead and change it. It shouldn't change much about your code. So with that, we have a movable cube that can be picked up and has physics interacting with it, no problem. Currently we can't pick it up. We have the logic for it, but we're going to have to add some more to that. So let's just add a player start in the actual thing, not the content. So we have a player start now. And as we changed it here, we'll also spawn in our FPS Superliminal. So now we're going to have to change that. So the changes we need to make here are a bit more important, let's say. So we'll start off with a few things. So the first thing we're actually going to do is, before we start making too many changes here, we're going to make a crosshair of sorts. So this is just a little thing. You don't actually have to follow this if you don't want to, but we're just going to make something so that the player knows an object can be picked up. So we'll call it, well, crosshair. So for the UMG crosshair, I'm going to make something very, very simple. So I'm not going to bother with having two images, a circle, and for instance the interior of the circle light up. I'm just going to make a cube that will change opacity if it's an object that can be picked up. So we're going to start with a scale box. We just want to make sure that it scales for the entire screen no matter what resolution the player has. Then we want a canvas panel, which automatically decides to fit. So I actually did that without saying anything, but when you have stretch, by default it will be scale to fit, and as you can see it does something weird with the panel. So what you usually want is fill, not the scale to fit. Then we're simply going to get an image, which will be our cube that we're going to change. So I'm just going to rename it to image crosshair. Now make sure it's a variable, because we're going to need that. Set its anchor to the middle, set its alignment to 0.5 and 0.5, which will make it easier to place, and set it to 0, 0 as far as position is concerned. Now I found that something like 20 by 20 is good. And to make it look a bit cooler, we're going to rotate it by 45 degrees. Now by default, we want to put it to a render opacity of 0.4. Now this is my opinion, feel free to change it however you want, maybe not even lower, 0.3. And we're going to create two small functions. The first one is going to be hover, and the other one is going to be unhover. Now we're going to make a boolean as well here, which we'll call is hovered. Oh, sorry. So normally I'd call it is visible, but is visible already exists as a function, so we can't actually have that. So we have to do it with something else. So on hover and unhover, for unhover we're simply going to set this to false, and we're going to set your visibility, so set render opacity to the 0.3 that we already set. There we go, and set hover to false. Now we can copy this pretty much, and for hover we'll put it to 1, it's going to be 100% visible, and hover to true. Now with that, we're done with the crosshair, we don't need it anymore. So back in our Superliminal first person character, we're going to make our event start. So for the event start, we have by default our parent begin play, because since we made a child of the first person character, that's what we have. So the first thing we're going to do is we're going to add our mapping context. So get a reference to our player character, and from the player character we're going to get input, and it should be apparently, oh sorry, I got that wrong, not player character, we need player controller. So get player controller, and then we want to get enhanced input system. And with that, we're going to add mapping context and attach it there. So for the context, we're going to obviously select our superliminal context. Next up on the list is we want to add our widget. So we're going to create a widget. And the widget is, well, our UMG crosshair. But we're going to need to actually create a variable for this, so promote it, and we'll call it as UMG crosshair. There we go. And we want to add this to the viewport. Now obviously we need a reference to it so that we can change it later in the code when we hover the objects that we want. So now the next thing we're going to add here, because we need one last thing for the event begin play, we can't do because it's a timer. So first we need to create the function for that timer, and it's going to be linked up with our crosshair. So we're going to call it trace valid target. So just open it on my other screen to make sure I don't mess it up. So in here we're going to get a reference to our first person camera, because we're pretty much going to be shooting straight ahead from the first person character to see if we actually hit something that we can pick up or not. So we're going to get world location for the camera. Then we're going to get forward vector. And this we're going to multiply, obviously, because we're going to determine which distance we want to go here. So for the distance, we're going to create a variable, because we're going to be using it a lot, which we'll call max range. Now max range is a float, which we're going to get here and attach. Now we can compile to change the value, and I put by default 3000. Then we're going to say line trace by channel. There we go. And we're going to attach this to the end. Oh, sorry, no, actually. We need to add these two and then attach it to the end. So I'm actually going to reroute this, because this can definitely be a function in itself, because we're going to use it a few times. So we want to does trace by channel. Actually, no, sorry. What we want to make a function is not this, I think. No, it is, sorry. Let me just double check that. Yeah, it is. So we're going to actually use this twice. So we're going to create a function because we use it twice. So this is just going to simply be line trace from camera. Simply call it that. And the outputs are the two outputs that you would get from a line trace. So with this output, the first thing we want obviously is going to be to check if the return value comes out as positive, so if we hit an object. If it does, we want to break, and we're going to tell it to cast to movable. Now, once we're inside movable, we actually can't immediately say, oh well, we hit something. That's good. We need to make sure that the thing is not locked. So we get locked. Actually, to be fair, it probably should be named is locked and as well as is held. That way it defines what it is instead of just a word. So if it is not locked, so make sure we either add the not or use the false, but we're going to do the not here because it'll be easier to attach it and more tidy, sorry. So let's do that. There we go. And so here we're actually going to do two more things. We're going to need a UMG reference, and we're going to get the is hover, so get that, and we're going to put a branch. Now, if it is hovered, then we don't want to do anything, but if it isn't hovered, then we want to type to hover. This way we avoid doing like a hover every time we call this function, and only do it when we start hovering again. Now on all the false here, we're going to add a reroute node here, another one here. Let's make things nice and tidy. There we go. Now with that, we're actually going to call another branch, which will be the same as this one, and this will do the opposite effect. So if we are hovering, then we want to say, well, unhover. So let's do that now. So with that, we've finished our function for tracing whether something exists or not. We can minimize that. In event graph, we're going to create our timer now. So what we'll call is set timer by function name. And the function name will be our trace valid target. So for me, I'm going to put 0.1 here, which means it will run 10 times each second. So that's not too much, but it's enough, precise enough that the player won't have a situation where he doesn't know if something can be picked up. So we're going to put it looping because we want it to happen every time, constantly without stopping. Actually, well, that's not true because we are going to stop it at some point, so that's why we're going to create a return value here and promote it to a variable. So we'll call this crosshair time. Now the reason for this is that when we pick up an object, we don't want it to trace because we're holding something, so we can't actually pick anything new up, so we just won't allow it to trace then. So with this, now we can test this normally. Let's go into the level, play, and if we hover normally a movable object, it should light up. So apparently it is not lighting up, so I did something wrong here. So let's have a look and try and find out what that is. So I accidentally set all the values I was supposed to set as the image, the actual canvas, so nothing was actually changing because of that. So let's go and there we go. As you can see, once we hover, it goes and lights up, so that we know that we're actually targeting a cube. So that the crosshair is now completely done, don't need to touch it again. And for the code here, everything is finished as well. So now we can actually get to picking up the object and moving the object. So you probably noticed that we're not actually using any pre-integrated logic for the pickup, and the reason for that is because it's kind of custom, because in Superliminal, the cubes and objects that you pick up don't actually really interact with the world, because usually you would want to have physics enabled so you can push objects away, but that doesn't happen because they automatically adapt to the closest object to their size. So they'll never actually physically interact with them because they're being blocked by them. So for that reason, I felt that making a custom system is a lot better than making it with, for instance, the physics handle or the physics constraints, because then I have to manage more variables than I actually need. So that's the reason that we're doing this manually, let's say. So to do this manually, we're going to need the event tick. So I can get rid of the begin overlap because we don't need that at all. First we're going to do is to make the new functions. So first we're going to make the pickup object. So let's call that here, and we're also, while we're at it, we'll add the drop object. So with the pickup and drop object, what we need is the keybind to do that. So let's add our IA interact. So in my case it's F, remember, whatever yours is. So for the interact, we're going to first need a variable that's going to represent the object that we're holding, because if we're holding an object, we need to release it. If we're not, we need to pick it up, if we can. So for that, we're going to create a variable we'll call held object. Now, held object can be a primitive component as well, because it's going to be a static mesh. Now, I could also put as a static mesh that component as well, but for instance, with a primitive, it can also then work for skeletal meshes normally as well. So I haven't tested that, but it should work as well. So think of it as the parent class of those two, of all pretty much components you see here, if I'm not wrong. So what we want to do is we want to do a get, and we're going to convert this to a validated get. And on trigger, so let's double check here by adding a print here because we don't want to make a mistake. If we press F, we get hello. If we hold F, it still only prints it once. If it prints it multiple times, that means that you need to go back into the IA interact and make sure that you add the trigger to pressed. Or add the press trigger, sorry. So now we're going to add our pickup object on false or is not valid, and drop object on is valid. So let's start with the drop object. This is the easier one. So for drop object, we're going to want to do another validated get. Now the reason for this is because sometimes we might call the drop from another function outside, and if we call the drop object when the character isn't holding something, then it will cause an issue because he's not holding something. So we need to make sure that this only executes if we are indeed holding something. So we want to get our owner, and the owner here will actually get a reference to the movable object actor, because even though we're attached to the component our first person camera, when we're going to pick it up, we're not actually attached to the, we're still considered as part of the a movable, which is a bit strange, but still makes kind of sense. So I'm actually going to here cast to a movable, obviously, but I'm gonna leave this one here because it might be harder to explain what we're going to change here if we don't actually do the rest first. So we're actually going to start with the pickup instead. So let's go and open that. So for the pickup, we're going to start with our line trace from camera. So we're going to need that here. And the first thing we're going to do is, once again, a branch to make sure that we hit something, because otherwise we can't pick it up. Then we break our out hit because we need to cast to our movable. So cast to movable. Now with cast to movable ready, we need to call the self pickup. So this is the function that we made earlier to make it simpler. So now we add a branch here, and on true, that means that we did pick it up, it's valid. For the parent component, we want to get our first person camera mesh. Seem to have made a mistake here. So apparently we can't use the primitive component, so I got something wrong here. So let me just double check what I put in the other project. So I'm actually going to change this as well then, just in case, back to a static mesh component. Let's get that there. Components, static mesh component. Change it. We've only used it once, so it's not too important. For self pickup, we're going to open it and change this to a, not wrong, it is a, sorry, so I'm actually, this can be a seeing component. So I actually got it wrong when I said what I said earlier. So it's a seeing component that we want, and the same thing should be okay for held objects. A seeing component should work as well. So change the variable. We can test. If it doesn't work, we'll change it back. That's fine. So first person camera attaches correctly. And now, with that in mind, we can get here our static mesh. Now the static mesh is obviously going to be our object that we pick up. So the reason is that we're going to set it here to our held object, and it does work. So we should be able to work with this. Now after that, we're going to need to create a small function here. Now the reason we're creating this function is to have a kind of smoother, let's say, attach. You don't have to do this. The only purpose of this function I'm going to make now is to, when you, for instance, let's say you have a cube and you click on the edge to pick it up, it will immediately teleport to the center of the screen, or the center of the cursor, which may look a bit odd. So we're just going to create something that will lerp that information instead. So we're going to get a relative location, and then we're going to go and create a custom event in the event graph. So let's do that, and we'll call custom event, which I like to call CE for custom event, and call it lerp location. Now this function is rather simple, to be fair. We're just simply going to call a timeline, and it will be called TL underscore, let's just call it lerp simply. Now attach the input to the lerp, to the play start, sorry. And we're going to need one input, and the input is going to be the start location. So I spelled that wrong. Start location, and it's going to be a vector. Now for the vector, we're going to reroute it here. So we're going to need it twice, and the first one is going to be a distance vector. and attach it to the V2. Make sure you have it on V2 because otherwise we're going to have an issue with negative values. We're then going to multiply this for a float, but first we need to do a lerp for the vector, and this lerp is pretty much going to be the new position. So multiply this here, make sure you drag from the vector, because otherwise you'll get a simple float multiply, which is not what we want. And we want to set x to 1. Now the reason we're doing it like this is because, as we did here, we're using a relative location. So think of it as being relative to the first person camera, and forwards for the first person camera is simply x1 and the rest 0. So that kind of got me stuck for a little bit because I was being stupid and forgot that it's relative. So we don't need to bother with getting forward vector or getting right vector. It's just simply x is equal to 1. That's all. So here we can call our CE lerp and attach that here. And let's just finish that function up now. So the update, we're actually going to first call, well, set relative location for our held object. So set relative location. There we go. With set relative location, we attach the return value, and we want to teleport because we don't want to bother with any collisions. Doesn't matter. On the output, we're actually on the finished, we're going to need another function, but we haven't made it yet, so we're just going to give it a second and do it after. Now we need to open our timeline, and we're going to set the length to 0.1 because we want it to be short. Now for me, 0.1 is what I chose. If you want it to be a bit longer, that's fine, or a bit shorter, you can do that. I like to call mine alpha because in most cases it's used for a lap, so we simply put it at 0. And then the second one, shift click, put it at 0.1 for time, or whatever length you set, and value to 1. That way it will lerp for us. Now if you want to see everything, you can just press F or put everything together. So with that, we're finished for our attach. Now let's finish the 2 of these and we can see how it actually works. So back in the pickup object, we need to do one last thing to be finished here. And that is, as I mentioned earlier, we're going to get our timer and we're going to call clear timer and then validate by handle. So we're simply going to call that here. That way the function isn't being called, we're not wasting calls for nothing. And finally, now we're going to need to create a few variables here. Now these variables are not going to be used immediately because first we're just going to do the pickup, but these variables that I'm going to make now are used for the scaling of the cube by the distance. So for that, we're going to get our held object again. So let's get a reference to it here, and we're going to get component bounds. With these bounds, pretty much we're going to be able to tell no matter what rotation the actual range the object takes up. So we're going to get our box extent and we're going to promote to a variable. Make sure it's a public one and not a local, and we'll call it starting bounds. Next we're going to need another one which we'll be getting also from the held, and we need to get world location. And for that we then need to, actually we don't specifically need to do it this way. We can simply call the same function as here, which should work as well, because I was originally doing a subtraction for nothing. So get relative location, and simply attach the relative location to v2. And with that we should have our starting distance. So call the variable start distance. Sorry, we'll call that starting distance, leave the other one. Okay, and finally one last one, which will be our scale. So get held object, and we want to get world scale. And with that, we promote it to a variable as well. Sorry, not a local one. And we'll call it starting scale. There we go. With all that done, we finished our pickup. Let's do our drop object. So for the drop object, pretty much we'll do what we did before with the other one, but opposite again. So this time we're going to call self drop instead of self pickup. And we'll then set our held object to empty because we're not holding anything anymore. So with that, we can also tell our crosshair to be unhover, because we no longer hold an object. Actually, did I do that in the pickup? Because in the pickup, we also want to say that we are holding something, so that we should have it be hover. Yeah, so I actually forgot that. So right before this, right after the time has been invalidated, we're going to get our crosshair and say hover. Drag control so you don't have to redo the two. Go. So with that, we finished our pickup. And now we can go to drop object. Now for drop object, we just did the unhover. And what we want to do is we want to copy from our event graph the timer being called. And we're going to put that again because now we're not holding anything. So we want to check once again if we can pick something up. Now once again, we're going to need another function here. But we're going to be adding that in a second. For now, it's not necessary. So with that, normally, we should finish and should be able to pick up cubes. So if we scan over and we press F, we pick it up. We release, we can drop it again. Now, as you can see, right now it's not doing anything. It's sticking kind of to where we had it on the side, but we want it to go to the middle. So to do that, I actually forgot here, I think, to set something up. Yeah, so we forgot to connect the alpha, which is why it's not actually moving. So let's do that. Now if we pick it up on the edge, it'll go to the middle, but it won't teleport there, it will smooth itself there. Now, you might have issues, for instance, if you do this, it kind of goes onto the ground, so it's not perfect. It's not a perfect method for doing this, but it's just a simple one. And either way, in the 0.1 seconds that it happens, it will then adapt to the distance, so you'll hardly see it go underground. So with that, we have a pickup object. As you can see, you can move around, no problem. You can drop it, it activates. But it's not getting any bigger, is it? So that's the next step we're going to work on now. So as you remember the variables we set up inside of our pickup here, we're going to be using these as, let's say, the default. And with that, we're going to be constructing the rest. So we'll start by going to our event graph. And we're going to add our event tick here. Now, here we're going to add a gate, which will allow us to deactivate it when we want to, instead of having a boolean with a branch, for instance. We'll do it this way. So it starts closed because we're not using it yet. And we're going to create a custom event here, which we'll call open gate. And as you'd guess, the second one is going to be a custom event as well, which we'll call CA close gate. There we go. So now we have our function set up, and as you guess, if you're probably aware, finished is obviously going to call that we've just finished lerping, so that we are now holding an object completely. So we're going to open the gate because we want it to start calculating the distance and moving the object accordingly. On drop object, on the other hand, we want to call the close gate because we're no longer holding an object, so we can't move the object. So now we get to the more math kind of side of things, and in the event graph here, we're going to create a custom function. So the reason I did this is because it's, when you do this logic initially, I thought about line tracing simply to the end and moving an object back and forth, because obviously it's very easy to move an object to the end where you hit a wall, right? But we don't want the object to be sitting inside of the wall, we want it to be in front of it. So instead of doing a simple line trace, what we're going to do now is kind of a, let's just say, a dozen of different box traces of the size that the potential cube would be based on the component bounds that we set earlier. So with those component bounds, we're going to say, well, hey, it's going to be this big at that distance. Can we spawn it there? And so that's how we're going to calculate our distance. So what we're going to do is a new function. This function will call custom box trace. So like that. Now for the custom box trace, we're going to need a few inputs. First, we're going to need the starting bounds. Then we're going to need the starting distance. Well, what start distance? That's where it's different. Same for bounds. Distance is obviously going to be a float. And then we can add another one for the debug type, but it's not necessary. We're going to need some return values as well, which will be the, this will be the size, sorry, the scale modifier. But then we're also going to need the new location. So for the new location, let's put it above because it's going to be the first thing we're going to use. There we go. So we can detach it and put it here for now. So we're going to say it doesn't take up too much space. So let's get started. So the first thing we want is we want to put our start bounds and promote them to a variable, a local variable we'll call L current bounds, because we're going to be updating them as we go. Next, we want to add a for loop. Now, for the for loop, pretty much is going to be how we determine how many cubes we're going to test, how many locations we'll test along in front of the player. So to do this, initially I had done 100 different traces, but it's not really necessary. It's awfully precise for something that doesn't specifically need to be. So instead, what we do is we get our max range. Sorry, max range with 1R. And we're going to divide it by 5. So in our case, that would mean 3000 divided by 5. So that's still kind of a lot of traces, but it's not too bad. Normally it should be manageable. So we want to then truncate this because we need to attach it to our integer. Now we're also going to add, instead of starting at index 0, we're going to start at 10. Now the reason we're starting at 10 is because we don't want the cube to be too close to the player. We want it to be a minimum distance, let's say, for that. So next what we want to do is we're going to multiply this by 5, because we actually want to be scaling the opposite of this, that although we're doing counts of like 600, we want to also multiply it by 5 on the other side so that we do still through max distance, or max range, sorry, even though the index may be smaller. We then want to convert this to a float, and then that float will be our local variable, which we'll call L current distance. There we go. So L current distance is set up. So what we're actually going to do here is we're going to need to... So we're going to add here our return node. We'll just get rid of that, we need one. And uncompleted means we made it to max distance. It means we didn't hit anything. So we need to do something there as well, so we can't leave it blank. So what we're going to do is we're actually going to duplicate our current bounds, and we're going to create another one we'll call new location, or location simply. So location will go into here. We're going to be calculating it in a little bit. And for the scale, what we're going to do is we're going to get current distance and divide it by start distance. Now remember that start distance is here and starting is the outside one. This is not the parameter. The parameter is start distance, starting distance is the actual variable we made. So with that, now this will set it to max distance if we finish the loop. Now, if we don't finish the loop, so here we're going to set the variables. So we get our, sorry, let me just double check something. So for current bounds, what we're going to do is we're going to need our start bounds. So we're talking about specifically start bounds that we have here, not this one. So we're going to update current bounds obviously at each loop because the bounds will be changing relative to the size. So what we need is a multiply. We're going to get this information here and we're going to apply that to the scale pretty much. Sorry, so you should not be, you should be a float, not a... So now with that we have the logic that will allow us to scale the object and scale the bounds. So now the next thing to do is to get our location. So for the location we're going to need the first person camera. We're going to do our typical get world location, get forward vector, and then we're going to multiply it by, this time we're going to get our current distance, which we calculated before, which will then determine how far away we are. So then we want to add these two up, and that will calculate our new location. So set that one here. Now with all this information we have the, let's say the starting point, we have the size. So with those we can now perform a proper box trace by channel. So call the box trace by channel. For the location we're going to use it for the start and for the end. Let's attach that. For the half size, we want the current bounds. Now actually, for the current bounds, what I noticed when testing is that sometimes you can end up, or most of the time to be fair, if you don't actually increase this value, I put 1.65, maybe it will work for you on 0, but I doubt it, on 1, sorry. But in my case, they would always be too small and the cubes would still be slightly inside of a wall, which I wasn't exactly sure why, because the current bounds, when showing them, for instance, on the individual movable object, it would always be correct and always be as big as the object, but for some reason the bounds here were a bit off. So adding a bit of an offset most of the time did work, worked every time. It just made it slightly a bit off the wall, but that shouldn't be too much of an issue. So next we want to check if we hit something. And so if we hit something, well, we don't actually need the out result because we've already done the calculations we need. And we simply are going to call a return node here. Now calling a return node here does the same as breaking our for loop. So that way, if we hit something soon, we're not going to bother calling all the 100 or so more different traces. It'll only do the one that it needs until it hits. So with that, we now have the logic to, well, actually resize our box. Now we just need to simply call it here. So let's get custom box trace. And we're going to get our starting distance and our starting bounds. Scale that. And so the first thing we want to do is we want to get a reference to held object, and we're going to say set world location. And for set world location, we just do that. Let's just add a reroute node to make things a bit tidier. And for the scale, we're going to multiply u by the starting scale. So like that, and then we're going to do here set world scale 3D. So world scale 3D, there we go. New scale, and with that, well, we should be done. Everything should be functioning correctly. Let's give it a try, shall we? Hopefully this works. So if we press F, as you can see, the object just works fine, and let's release it. So I'd say that got a bit smaller, and that definitely got smaller. And if we put it above our head, it's definitely scaling, and you can't see any difference. On the screen it looks exactly the same. The only difference being lighting, obviously, and that's exactly what we want. If we release it, it gets smaller. Same thing here. Let's go ahead and actually add a wall to see if that works. So we'll add a basic shape, a cube. We'll scale it up. That. Let's try it again. So if we pick it up, it drops right in front of the wall, as you can see. If we pick it up again, let's try and walk towards the wall. It's gotten smaller. And we can do the same as much as we want, so it becomes a tiny little cube. And this mechanic is, I don't know about you, but I just find it so satisfying for some reason. It's just so cool. I find the mechanic of Superliminal so cool. I'm so glad that we were able to make it here. So with that, the basics are completely done. Right now, you can play Superliminal on Unreal Engine. So we have one last thing to do before we actually finish the actual tutorial. I'm sorry, I kind of skipped ahead. Apologize for that. So we actually still have to make the rotation. So let's actually go ahead and do that before we end the tutorial there. So to do the rotation is pretty simple. We just want to get our IA rotate. So with IA rotate, we're going to get the action value and multiply that by 5. Now 5 is just because otherwise you're really scrolling a lot for nothing, because you don't want to move 1 degree at a time. That's very slow. But we're actually going to need a few other things. So in my case, I did this simply by adding the left control and the left shift, because that way I don't have to have an input action for this because it's very small. We're just going to simply call a few booleans here. Sorry, so we're actually going to duplicate that, it's easier. So the booleans are going to be simply for shift held and what's it called? And control held. Go. And so this is simply going to be called here. Shift held is true on pressed, and it's false on release. Same thing for the other one. simply, sorry, not the, there we go. So it's true here, and it's false here. Now, this is simply so that we can change the different angles that we're rotating on. So in my case here, I'm going to add a reroute node and a reroute node here. We'll add another one there, and we're going to collapse this to a node because it's a bit easier to use. So we're going to do rotate object because it's going to get a bit messy, so it's might as well have it be tidy in here, or at least not visible. So the first thing we want to do obviously is check if we have a held object, because if we don't have a held object, can't do this. So we'll add our held object, and we're going to call a reroute node here, a reroute node there, just to make it tidy, because we're going to need a bit more space than that. Pull that all the way along, and we're going to say set world rotation. Now you can also do this with relative location, if that's what you want, that works as well. But I'm just going to do it with world. So we're going to get world rotation here. Going to split, because you can't actually modify rotation if you don't split them. It's kind of annoying, but that's just how it is. So we want to get the input pin. We're going to add a reroute here, get another one here, and another one here. So what we're going to do is we're going to then say make rotator here, and we're going to add a plus for the X, a plus for the Y, and a plus for the Z. So with these, we're very simply going to do pretty much simply attach them like that. So what this will do is, for instance, this one will modify the X, this one is going to modify the Y, and the last one will modify the Z. And it will modify it by the value, or the input that we're getting from outside. So last one here, attached, and there we go. So with that, we've attached them, and now we just need to do a basic select. And to do that, we're going to say select rotator, and the selection we'll use is if shift is active. Now this doesn't matter. You can do it whatever order you want. If you want to do it X to Y to Z, that's fine. If you want to do it Z to Y to X, it's also okay. It doesn't matter. Whichever you want is better. I'm using shift here. You could use control as well. It works just the same. So I want to have this be here, and actually it's better to do it that way. So I'm just going to reorganize that a slight bit, because you want to have it so that you know that if you press control, you get the top one, because it's pick A. And with that, we're done. That's simple. It's not very difficult making the rotation of an object. It's just a bit messy. I wish it could be done a bit cleaner than this, but I don't know of any method for that. So maybe you do. Let me know if you do in the comments. So let's go and pick it up. Now, if we scroll by default, we get this. If we hold shift, we rotate like that. Now, one thing to note is that when rotating with, well, in my case it's shift, in your case it may not be shift. So the problem is when you use shift, so in my case shift here is for the pitch. When you rotate on the pitch, there seems to be an issue where it will always block at 90 degrees and always block at minus 90 degrees. So I'm not exactly sure why that is. So be warned. I don't even know if it's possible to say, for instance, usually what I would suggest doing is you add a bit more code here and say if it's equal to 90, then change it to minus 90. But the thing is, it's not even doing 360 degrees. So that's a very strange issue that I don't seem to know what is causing. So, but it still works for the basics. Obviously, if you're using something that has an actual difference, let's say in our case it's a cube, so it doesn't matter if it's upside down, nobody can tell. But in another case, you might need to look into fixing that. But I won't be doing that for this because it's not necessary. But thank you anyway for watching. Now we are officially done with the movable cube or movable objects. So I hope you enjoyed. Next video will probably be about making the portal system that you saw in the showcase. So look forward to that. Thank you for watching. I'll see you in the next part. Goodbye.